In this video, I will explain the physics behind a squat by applying the concepts into a real-life full squat process example. Take a look at this clip as an example. People might only focus on whether he or she has the ability to stand up. However, behind this entire squat process is an interaction of many different forces that allows one to descend and ascend. Now, I shall explain in details how each physics concept is being applied and the result of it. With the bar on the back, the total force acting downwards is the total weight of the body and the barbell due to gravity. Before squatting, there are two more concepts that are important. Newton's third law explains that the downward force from the weight acting on the ground through the feet causes the ground to exert the same force in the opposite direction. Additionally, as forces are in equilibrium, Newton's first law explains that balanced forces allows one to be at rest and in this situation would be standing still. As the person starts descending rapidly, the legs produces a small force on the ground and according to Newton's third law, this results to the ground pushing up on the feet with the same force but in the opposite direction. Since the downward force from the total weight remains larger than the upward force from the ground, Newton's second law tells us that there is a net downwards force and therefore accelerates to the bottom of the squat. As I prepare to ascend from the bottom of the squat, Newton's second law application proves that I will require an upward force from the ground that is greater than the total weight acting downwards by the weight. The result of this will be a net upward force and therefore causing me to accelerate back to the standing position. This is possible as the legs exert a strong downward force into the ground, and according to Newton's third law, the ground responds by exerting an equal and opposite upward force on my feet. However, take a look at the clip where the person uses a heavier weight. He is unable to ascend, and that is due to the legs being unable to generate a force larger than the weight. This explains Newton's second law as he is unable to generate a force greater, which results to no resultant force upwards. Hence, he does not accelerate upwards. Last but not least, when I ascend upwards, my legs is required to do work and it can be calculated using the formula work done equals to force times displacement. To calculate it accurately, we have to calculate the force upwards generated by our leg that has to be greater than the force acting downwards by the weight multiplied by the displacement required to return to the top of the squat in order to find the amount of work by the legs.